Hello everybody, today we're going to talk about the trigonometry, one of the most important parts in math, in school math, in university math, and so on. So before we start talking about the trigonometry, let's just remind us something about right triangles. So we have the triangle, and this triangle is right if one of the angles of this triangle is 90 degrees. So, for instance, this angle will be 90 degrees. This triangle can be called right, and it is indeed called right. So let's just name the tops of this triangle like ABC. Just rudely to say, let's name this triangle. Okay, so the longest line here, AB, that lies opposite to angle C, is called hypotenuse of this triangle. Hypotenuse is always the longest line in the right triangle. And the rest two lines, between of which the angle is 90 degrees, they are called legs. So BC is leg and AC is leg. Then we are going to trigonometry. Just let's get known to some functions in trigonometry that are so important. So assume that we've taken the angle A. So let's declare some angle theta, which equals angle A. So here we have such trigonometrical functions. So the sine function of theta is. So now we need to find the opposite leg to the angle A. The opposite one is BC, since it doesn't lie next to the angle A. So it's an opposite one. It's shown right here. So we need to take the ratio of the length of the opposite line to the hypotenuse. I remind you that the opposite line here is BC, and the hypotenuse here is always AB. The next function is the cosine of theta, and it equals the ratio of the adjacent leg, that means AC, since it lies next to the angle A. So the ratio of AC to the hypotenuse AB. Okay, next, tangent of theta. So it's the ratio of the opposite line to the adjacent one. So the opposite line, opposite leg here is BC for the angle A. And the adjacent line is AC. So just one interesting fact is that tangent theta could be written in another way. So the tangent is either the ratio of the opposite leg to adjacent leg, or it can be also the ratio of sine of this function to cosine of theta. And it's indeed so. If we just substitute these two fractions to this equality, we will receive BC over AC. Okay, and the last but not least, it's the cotangent of theta. It is the opposite function of tangent. That means that the cotangent of theta is the ratio of the adjacent leg. Adjacent leg for the angle A is AC. The ratio of adjacent leg to the opposite one. The opposite one is BC. And we have two more functions, but they're not that important, but it would be useful to remember. So the second of theta is the same as the ratio of hypotenuse to the adjacent line. The adjacent line for theta, which is the angle A, is AC. Since AC lies just next to this angle. The second can also be written like 1 over cosine of theta. And also we have cosecant of theta. It equals the ratio of hypotenuse to the adjacent line, or just 1 over sine of theta. Here I guess that's it for the functions. So let's just look at the way these functions work, these functions behave. So let's consider the coordinate system x, o, y. X here o, here y. And let's just draw a circle with a radius 1. Although it's not that circle, and I'm not such great artist, but this can be a circle as well. So let's just mark a point on the circle. Let's call it A. It has x coordinates and y coordinates. They are called abscissa and ordinate. Oh, and let's just draw a line from O to A to get the radius of this square. Or no, of this circle. My bad. The length of AO is the radius. That means 1. And let's just draw a perpendicular from A to the OX axis. So it's this way. Let's mark this point like B. And here we have the right triangle OAB, where OA is a hypotenuse and OB and AB are legs of this right triangle. So assume that we've taken angle theta, the angle O, AOB. So the sine of theta will equal the ordinate of the point A. Since the radius is 1 and the ratio of the opposite leg, that means AB, to the hypotenuse will equal just the ordinate of the point A. Almost the same algorithm with the cosine, but we should take the adjacent leg. That means the abscissa of the point A. So the tangent function here is just ratio of sine to cosine. It's easy. And a cotangent is the ratio of x to y. That means the adjacent to opposite one. Here is clear, yeah? So let's just look at the sine and cosine's behaviors. So talking about sine, assume that we start here from the point 1, 0. At this point, sine equals 0. So the sine of 0 degrees is 0, while cosine of 0 degrees is 1. It reaches the maximum value. So as long as we go to the intersection of circle's curve and a y-axis, an OY-axis, it is here, the value of sine function decreases till 90 degrees. That means the sine is increasing, but the cosine will decrease since the abscissa of the point will fall till 0 here. But the sine of 90 degrees will be 1. So this point will be 0, 1. The cosine of 90 degrees will be 0. And that means that the tangent of 90 degrees does not exist, since we cannot divide by 0. Let's just remind us that the tangent is the ratio of sine to cosine. That means the cosine cannot not equal 0. So it cannot. So the theta cannot equal either 90 degrees or 270 degrees. So it's here. That means 0 minus 1. At this point, the sine will be minus 1. Since the sine is, rudely to say, the projection of the ordinate of point A. Let's assume that this is point A. So here we see that minus 1 is the ordinate. And the ordinate is the sine as well. So it's the sine of 270 degrees. It's minus 1. So let's just summarize and draw the graphs so that we could understand how do these two functions work. So looking at the algorithm of how does sine function and cosine function work, we can just sum up that from 0 till pi halved, where pi is 180 degrees and pi is approximately 3.40. It's the constant. It's the most useful constant in the trigonometry. Not only even in geometry. It can also be used in algebra. So from 0 to pi halved, that means 90 degrees, the sine function will increase till its maximum value, which equals 1. So the graph will be this way here. However, the cosine function already has the maximum value of 1 at the point 0, since the cosine of 0 degrees is 1. And from 0 to pi halved, it will decrease till 0. So the graph will be dotted here, so that you could understand. So when going till 180 degrees, that means till pi, since pi is 180 degrees, the sine will begin to fall till 0. And the cosine will reach its minimum value of minus 1 this way. And there it goes from 180 degrees to 270 degrees. That means 3 pi halved. The sine function will reach its minimum. However, the cosine will begin to increase its value to 0. And there it goes. These functions are periodical. They have its own period, the value after which the values will repeat. They have the period of 2 pi. That means 360 degrees. That means if we have sine x, and this argument x was added by 2p times k, where k is any integer number, or not necessarily integer, just any number, any real number. That means that this will be absolutely the same as just sine x. And it works with cosine as well. So this way. The periods of tangent and cotangent are just pi. That means 180 degrees. So that means the tangent of x plus pi times k is the same as just tangent x. With cotangent, it's the same. So that's it for today. If you like this video, please subscribe and like this video. See you next time.